Next topic we'll discuss is IUPAC nomenclature of coordination compound or complex compound. So the thing is, we'll take example. There are many rules, but we'll not go into rules, discussing about the rules. We'll take examples and then we'll understand how to do the naming. So the thing is, first example we'll take is this. Platinum. There is this chlorine and bromine. So the thing over here is that in this complex, if you see the coordination compound, like coordination pair is first and then a counter ions, right? Means whatever comes first, that is positive, it will have a positive charge on it, and whatever comes later, it will have the negative. Like whatever salt, whenever it is a NaCl, Na is positive, Cl is minus. MgCl2, Mg is positive, Cls are minus, right? Whatever comes first, we write positive. So in a coordination pair, we start naming. The rule is that if a coordination pair is first, if you are naming that first, right, you will start with the ligands. Now if you see in this case, there are different ligands. This ligand is called as a chlorido because the ligand is negative. This ligand is nitrosyl. This ligand is nitrosyl. This ligand is amine. See here, double M. This amine is double M, you have to write compulsorily. So A, then C and nitrosyl, like alphabetical order. So how I'll write is that triamine, then dichlorido, then this ligand is nitrosyl. Then what is this? This is platinum. Now if platinum is in a, like if this coordination pair is negative later, okay, negative, then we will not write that to be platinum, we will write that to be platinate. Okay, if iron was there, we would have written, if it was a negative coordination pair, means here there should be a negative, means later, first counter ion, then coordination pair, we would be writing that to be like ferrate, right? So here it is platinum, it is a coordination pair is positive, that's why as it is platinum I will write. Platinum, and in bracket there will be oxidation state which will be coming on that. How to find the oxidation state on platinum? I will put that to be is equal to X plus 3 into ammonia is a neutral ligand, 0, it doesn't contribute to any charge over here. Nitrosyl is also a neutral. How many? 1 is there and 0. Chlorine, 1 chlorine contribute to -1 charge. So 2 into -1. And over here you see there are 2 bromines, right? So how much is this contributing? This is contributing it to 2 into -1. 1 bromine is minus. So this is contributing to -2 charge. So what should be on a coordination square? +2 charge. So equals to what? Equals to +2, right? So X plus 0 plus 0 minus 2 plus 2. X is equal to +2 plus 2. X is equal to +4. +4 of charge. And this. Then done. Coordination pair is done. Then outside it is what? Bromide. Done. This is what the IUPAC nomenclature. One more example we'll do. Yeah, here coordination pair is later, means coordination pair is negative over here and the counter ion is positive. There are 3 potassium. So we are not going to write, like many students make this mistake. Whenever they see a 3 potassium, they will write tri-potassium. No, we don't have to write that way. We will just write potassium. Like in the previous case, we just wrote bromide. We did not write dibromide, right? So whatever may be the number attached to that, we will be writing just potassium. We are not going to write di, tri, all these things. So what is coming first? counter ion is first, so I am writing potassium. Okay, potassium, single T. Then leave a space between a counter ion and a coordination sphere. Coordination sphere, there is a fluorine, right? And chromium is there. So ligands, we name the ligands first. So hexafluorido. This is what? Hexa. Because fluorine is a negative ligand. That's why we write fluorido. Ligand is negative, not a coordinate. This fluorido, chlorido, bromido, we use it for the negative ligand and not for nothing to do with the coordination sphere. Whether it is a positive or negative coordination sphere, we will be always writing negative ligands to be fluorido, chlorido, bromido, nitrito, okay, cyano. All these are negative ligand irrespective of where they are present, whether it is present in a positive coordination sphere or a negative coordination sphere. So hexafluorido, then chromate. Because over here chromium is present in negative coordination sphere, that is chromate. In bracket I need to write oxidation state of the chromium in Roman number, right? So this is 3 potassium. This is contributing to how much of the positive charge? 1 potassium is +1, it is group 1 element, right? So this is 3 into +1, which is equal to 3. So this is equal to +3, this is equal to +3. So what should be this? This is equal to -3, isn't it? So chromium I am putting X plus 6 into -1, which is equal to -3. X minus 6 minus 3, X is equal to -3 plus 6, X is equal to +3. So this is the thing. So this is the IUPAC name of this compound. One more example I'll take. Platinum, En twice Cl2, and this is 2 plus. If you see in this compound, there is no counter ion given, it is just written a positive 2 charge over here, and means it is having a +2 of the charge. Now if you see over here, En is written. En means what? Diethane 1,2 diamine. Whenever you have ligands like this, in which already there is words like diethane, di word is there, right? So we'll not write this name as a diethane 1,2 diamine. The coordination sphere is there, so we start writing ligands first. So this is ethane 1,2 diamine, this is chlorido. C comes first, right? So I will write dichlorido, because it is negative ligand. Whether that is present in a positive coordination sphere or negative coordination sphere, I will be always writing this to be chlorido. But metal, remember this metal atom, whenever it is present in a positive coordination sphere, we write that to be platinum, and when it is present in a negative coordination sphere, we write that to be platinate. So dichlorido, and this is what? Bis ethane 1,2 diamine. Bis ethane 1,2 diamine. See over here, single M. Like this is like an organic IUPAC nomenclature, and only when ammonia NH3 present as a ligand, there we write a double M. Just take care of this, right? Bis ethane 1,2 diamine, and this is what? Platinum, just platinum. In bracket, what would be a charge? Let's see. I am putting this to be is equal to X plus 2 into 0, because En charge is 0. Like how we get to know? You should know this. You should by heart which ligand is positive, which ligands are negative, okay, which ligands has a neutral charge. All these things you should by heart. It is given in NCERT. So this is 2 into -1, which is equal to +2. This. So X plus 0 minus 2 is equal to +2. X is equal to +2 and +2. X is equal to +4. So this is what? This is +4. Now, when the counter ion is not given, you just write this to be ion. So this is how you do the nomenclature. Okay, now there is one name is given, and we need to write a formula of that compound. Name is given, we need to write a formula of that compound. The name is given. The question is write the formula of the following complex. Like this is what the name is given: penta amine nitrito O. Nitrito O means here NO2 is connected through oxygen, because nitrito, NO2 is an ambidentate ligand. Sometimes it connects through nitrogen. That time we write it NO2, and when it is linking through oxygen we write ONO, right? So cobalt, this is 3, and ion means you don't have to write a what? Counter ion in this case. So I will draw. Platinum is there. This is a ligand. How many? Sorry, cobalt. Yes, cobalt is there as a metal atom. Pentaamine. How many amine? 5 amine. Pentaamine. Nitrito O. Nitrito O means what? Instead of writing NO2, you will be writing ONO, because here this is how you represent ONO. Then the ligands are done. Now what they are saying is that on this there is a charge of how much? Your charge, this is not given, this is we need to find, right? So here cobalt, they are saying it is 3 plus 5 into 0. NO2 is -1 plus -1, which is equal to what? X. Like that is what I am finding, no? Which is equal to X. So this is 3 plus 0 minus 1 is equal to X. X is equal to plus 2. Means over here X will be what? Plus 2. This is how you will be writing the answers. It is very simple. You can score maximum marks. Coordination compound is the simplest topic, and also it is time saving topic. You can solve many, you can answer lot of questions in a lesser number of time, and you can get more marks for this. Okay, very scoring topic. Don't miss anything. At least with respect to IUPAC nomenclature, it is very simple. It is not complex like an organic IUPAC nomenclature.